Okay, good day, everyone. We'll start in a few minutes. We'll let people come in. So I assume that everything works. If you don't hear me, maybe put it in the chat somewhere so that the tech team can fix it. But we'll wait 2 or 3 minutes before we start. Okay, I see that some people are still coming in, so I'll give it another 30 seconds or so, 45 seconds, and we'll start. Okay, so I think we can begin unless the team tells me not to. Good day, everyone. My name is Bruno Charbonneau. I'm a professor of international relations at the Royal Military College Saint-Jean, Canada. I'm also the senior scientific advisor at the NATO Climate Change and Security Center of Excellence. I am and will be your host for the CCASCOE Speakers Series. So welcome everyone to our first episode. The Speakers Series aims at bringing our community together, at building bridges between different expertise and experience, at contributing to the production of climate security knowledge, policy, and practices, and at introducing you and us to different perspective, and hopefully also at encouraging us all to engage in healthy debates. So this is our first episode, our first year, so you can expect some experimentation in the format in the coming episodes as we move forward and see what works best. I would certainly welcome your feedback and ideas. If you have any suggestions in that regard, you can reach us on the website or through the website. Today, the format will be very much classic. Our guests will speak for about 20 to 25 minutes, and then we'll open it up to questions. The conference part of our session will be available later on the CASCO website as well in the YouTube channel. So if you want to watch it again or share it with other colleagues. I will also encourage you to submit your question in the Q&A tab, so you should have access to that on your screen. So we will monitor that tab and use it to ask you a question, to ask the questions or your questions to our guests afterwards. So without further ado, I'm very pleased to introduce our first speaker, Dr. Denis Dufour of the Canadian Space Agency. Dr. Dufour has a PhD in atmospheric physics from the University of Toronto, where he worked on the pre-launch characterization of Canada's SciSat satellite for stratospheric ozone monitoring. Uh, Hopefully I got that right. Following this, he led the development of several novel optical and spectroscopic instruments for terrestrial and space applications in startup and industrial settings. Notably, he spent 11 years at the Institut National d'Optique, the National Institute of Optics in Quebec City, We're working extensively on uncooled infrared sensor technologies. Now at the Canadian Space Agency in Montreal since 2022, Dr. Dufour is the manager of the radar and antenna group and is the mission manager for the Wildfire Sat constellation. So today he will talk about the impact of climate change on space operations. Denis, welcome, and thank you very much for being with us today and agreeing to do this. Very happy to have you here. Very much looking forward to hear from you. The floor is yours.
Thank you very much. Thanks for the very nice introduction. So yeah, I guess I will start the presentation. I will just here. Okay, great. Okay, so yeah, today I'll be talking about impact of climate change on space operations, but in fact, the presentation would also touch on how the assets we have in space can also help to monitor the effects of climate change on Earth. So as an introduction, so why this talk? It stems from a request we had from CCASCOE back in October of last year, where they reached out to us because they were looking for assistance in evaluating the impacts of climate change on space. And we said, sure, we'll see how we can help you with this. And so we asked for more specific questions like what aspects you're looking for. In response to that, we did some internal study, and a lot of that was done actually by, I want to give credit to Dr. Corinne Bourgault-Brunel, one of my colleagues here, who did a lot of the research to find answers to those questions. And we prepared a white paper that answers these questions, and that was delivered in January of 2026. And so this talk is essentially highlights from that, just to show some of the interesting findings that we had from that study. And so these are some of the topics that we'll address, that I will be addressing. So, and these reflect the questions that were asked to us in this matter. So first, just briefly talk about some of the space-based assets and data sets that are used for climate and environmental monitoring. Then talk about how climate change can be affecting the environment of space around the Earth, and what impact that has also, well, that plus also the impact of climate change on the space systems, not just in orbit, but also the infrastructure on the ground. We'll also touch on the sustainability and environmental footprint of all our space activities, and finish with talking about what are the data sources and information that is available and how that is being shared across technical and institutional communities internationally. So to begin, I think it's good to start with what is really driving climate change. And essentially, the main driver for climate change is changes in the composition of the atmosphere. And by that, we mean the concentrations and distributions of different gases. So, of course, greenhouse gases, but there's also other trace gases that can have some effects. Aerosols, clouds, so the distribution and the concentration of those will create warming and is creating warming mostly in the troposphere, which is the layer of the atmosphere that's right near the Earth. And because of that, that warms the ground and sea, but it's not uniform everywhere. And that's an important thing to keep in mind is that, as you can see on this map here, which shows the trend of temperature increase since, well, between 1948 and 2018, you can see that the temperature increase is much higher in the north. And in particular, if you notice the northwest of Canada here, so here talk is mostly focusing on Canada, but in general, the northern regions are seeing about 4 times higher rate of change than the rest. So that's an important factor to keep in mind when we're thinking about ground infrastructure, that these areas are going to be probably more at risk of the impact of climate change. So how do we monitor climate change? So the WMO, World Meteorological Organization, has come up with a list of essential climate variables, ECVs, and what they are physical, chemical, or biological variables that contribute to the characterization of the Earth's climate. And so monitoring those is key to understanding the effects of climate change on Earth. And so a lot of these can be measured from space. And so there's here you can see in the four columns here things that we can measure from space. So here I separated the ECVs in atmosphere, land, and ocean. So you can see for atmosphere things like precipitation, the radiation budget, so how much radiation is being emitted by the atmosphere, temperature, water vapor, wind speed, aerosols, gases, ozone. So all of these things can be measured from space using Earth observing satellites. As well on the land, there's many things that we can measure. Again, the temperature, but also how the changes in topography of lake and rivers, glaciers, permafrost, snow cover, biomass. All of these things are also important markers of climate change as well. And for the ocean as well, there's many things we can measure there, like ice, currents, salinity, temperature. And all of these variables are indicators or can help us understand the prevalence of extreme events. And so here I list some extreme events. And these are also, by the way, the extreme events, things that can be measured from space to some extent, like the impacts of floods, drought, heat waves, wildfires. As I mentioned in the intro, I work on a constellation called Wildfire Sat that will be providing better coverage of wildfires. So all of these things that you can see here can be measured from space and help us understand climate change and also the effects that can result from climate change. And so this is just a few examples of some of the satellites and missions that currently exist for some of the assets that we have right now to measure climate change and environmental. So there are many. There's a list on the CEOS website that you can look at that lists over 80 active satellite missions and from various government agencies and industry. And these are all measuring ECVs, as I mentioned in the previous slide. One thing to keep in mind when with these missions is if we really want to look at the effect of climate change, we need a long data series, right? So you can't just look at what is happening year to year. You have to look at trends. And so it's important for organizations that plan future missions to look at where the gaps can occur and make sure that there are plans to cover those in order to keep a good track of how these things are changing. So these are just a few examples on this table. So for example, in the US, NASA had an A-train, which was launched this now going back 25 years that had a whole bunch of satellites close together in a similar orbit, so they could do coordinated measurement of a whole bunch of ECVs related mostly to atmosphere, but also to land. There's the Landsat family of satellites that does multiple purpose monitoring of various variables. There are things like IceSat that measure ice, clouds, land elevation. So these are more active sensor satellites. NOAA and EUMETSAT both have operational weather satellites. These are in geostationary orbit and they're used to do the weather forecast, but all that data is also very useful for looking at climate change trends. In Canada, we have a few satellites up there. So SciSat and OSIRIS are two that were also launched about 25 years ago to measure things like stratospheric ozone and trace gases. And then we have also the RadarSat family of satellites that is one of the things that Canada has a particular strength in that technology of synthetic aperture radar. So we measure a lot of ECVs related to land and ocean. It's also worth noting that commercial companies are starting to make inroads. And so there is a company in Canada called GHGSat that was a commercial venture, and they're quite successful now in monitoring the methane emission sources. So we're seeing more and more commercial ventures coming as well that can provide data for looking at climate change. I'll go to the next slide. And so the previous slide was showing what's there now, but we also are aware that there are gaps and we need to plan for the future. And so these are just two missions that as an example, that Canada is pursuing to fill in some of these gaps that we're seeing coming in the future. One is, or that are actually there now that we need better monitoring. So one is the Arctic Observing Mission. So this is a mission proposal that we're hoping to get full funding for, but that would essentially provide 24-hour coverage over the north. So everywhere north of like 45 degrees, 50 degrees north. Right now, we don't have persistent coverage over the northern regions because the geostationary satellites that are there orbit around the equator. So there's a gap there that we could really fill in. The weather satellites that are provided by NOAA and EUMETSAT. Right now, the whole north there is lacking in good weather data, which also has implications beyond climate, but also for sovereignty and having weather services. It's good to have that coverage. So this is a big mission that is planned in Canada right now that will also measure greenhouse gases, air quality, and space weather. And another one is called HAWK. So the HAWK mission would measure things like aerosol, water vapor, ice clouds, all these things, all important variables for climate change that are currently either not measured or not measured enough. So these are two initiatives that Canada is developing that, if all goes well, will be launched in the 2030s. There was another question in our study that asked about what are the technologies, sensors, and platforms used to collect climate and environmental data. So I'm not going to go too much into the technical detail here, but we tried to kind of group it into different types of sensors that for different types of applications. So, for example, if you're interested in atmospheric gas composition, then typically the instrumentation that would be used are like high resolution spectrometers. So there's a whole bunch of different technologies that can provide that information. Temperature and radiative budgets, there's radiometers and different sensors that are used for that, spectral radiometers. Then there's a class of sensors that we call active sensors, and those are the ones that actually need a source as well as a detector. So for example, the two classic ones are LiDARs and radars. So in both cases, in the case of LiDAR, you send a laser, it probes the ground, and then you get the return signal. So these types of sensors can be used for things like measuring biomass, land cover, snow, topography, things where you want a signal return to measure. And it's the same principle that works for radar, but in a different wavelength range. And finally, if you're looking at things like land composition, water quality, then you want to combine spectral information with high resolution imaging, typically. So there's a bunch of technologies, either multispectral or hyperspectral imagers that are used for those particular applications, combining high spatial resolution with spectral information. Okay, so moving into a different topic now. So how does climate change actually affect the space environment around Earth? So we did a little bit of digging into this. It was actually an interesting topic. We hadn't really pondered much on our end. But what we did find, well, first of all, going back to how climate change is affecting the atmosphere. So as I mentioned earlier, it's warming. The greenhouse gases are essentially trapping heat in the troposphere. So that's why the Earth's surface is warming. But that has actually the converse effect of cooling the stratosphere. So although the troposphere is warming, the stratosphere is cooling. And that cooling actually reduces the density of particles in the atmosphere. So in the atmosphere, even when you start getting into what is called low Earth orbit, so 200 to 1,000 kilometers, in those lower altitudes, it's not a vacuum. You still have some molecules from the Earth's atmosphere that are present. And there are some studies that are starting to show that because of this cooling of the stratosphere and the reduction of the atmospheric density, it's reducing the number of those particles in low Earth orbit, and that has the effect of reducing satellite drag. When you have satellites in lower Earth orbit, inevitably there's going to be some drag from these particles that will gradually slow down the speed, and then these satellites, if nothing is done, will burn up into the atmosphere. And that's just the fact. So if you reduce the number of particles, then there's increasing evidence that that could mean, as a consequence, that the satellites will deorbit more slowly. So that could mean that we have the satellites stay in orbit longer, which could be a good thing. It could mean that, for the satellites that work well and we want to keep for longer, that's good. But it also, more satellites means an increased risk of collision and debris. So these are things that are interesting to track. Right now, when we plan our space missions, this is not something that's being considered, but it could be, it's definitely something we're going to keep an eye on to see if we need to factor this potential climate change effect in our space missions. So aside from space, climate change can have an impact also on the ground infrastructure that is needed for satellite operations. So because of climate change, ground stations and communication networks can be increasingly exposed to extreme events. So for example, extreme weather events, increased freezing rain. So that can affect the reception dishes, for example. Floods, more wildfires, in northern regions in particular, there can be effects like permafrost thaw, and rising temperatures that can cause problems for the infrastructure. And just to say that high latitude ground stations are increasingly more and more vital for two reasons. One is that many of the orbiting satellites that we have operate in a polar orbit, so they actually orbit from North Pole to South Pole. And what that means is that you have many satellites that are converging in a North Pole. So there's a need to have, as there are more and more satellites, there's an increasing need to have more and more ground stations in northern regions. So in Canada, we have a station in Inuvik, but there's also like in northern Europe, Svalbard and a few other regions in the north there that have a lot of ground stations. And so since the effects of climate change are more pronounced in the north, it's interesting to see and important to see how these might affect these ground stations in the future. And one example that this is happening already is an interesting example. In 2023, Canada had one of its worst wildfire season in history. And so we typically think of fires occurring in the south, but in reality, many wildfires happen in the north. And in fact, in that summer, there was a wildfire in the Northwest Territories in the far northwest of Canada that severely damaged a fiber optic communication link with the Inuvik satellite station facility. And so that really had some significant effects on the data transmissions and data flow from the satellites to the other infrastructure. So in response to that, they've since then added a separate link as backup. So more and more in the north in particular, as climate change is affecting the regions where fires occur and permafrost, we need to keep that in mind when developing the ground infrastructure for our satellite stations. And this is just a graph that we did to kind of illustrate that a little bit. So here we can see for Canada, so the red dots are where our government-owned satellite ground stations are. So on the upper left side here, the red dot is the Inuvik ground station I was talking about earlier. And that fiber optic link that goes south goes right through an area where there's a lot more and more wildfires. So all the brown dots here are where wildfires have occurred in the past several years. So you can see that Actually, going to the northwest of Canada, that's where a lot of our wildfires are happening. So we need to keep that in mind that more wildfires can have effect on infrastructure. So not just the buildings, but also the communication links and other support infrastructure that we need. We also have some stations that are more in the south. So the one near the center of Canada there, Prince Albert, also is near an intense wildfire zone. I also put in blue circle there. This is a planned launch station rocket launch station that Canada is planning to develop, and that one is near the ocean in Nova Scotia. But again, sea level rise is something that we should probably consider when we're designing infrastructure near the coast. So that's another aspect. And finally, on this graph, the different colors represent where the permafrost actually is. So we also need to keep that in mind that as global warming is thawing the permafrost, and as I was showing earlier in one of the first slides, more intensely in the northwest, you can imagine that a lot of the permafrost there is going to be melting. And so any infrastructure that's in these regions, we need to keep that in mind for what effects that could have on these infrastructures. So another topic was to comment on the sustainability of an environmental footprint of all these space activities. So one topic is orbital debris. So as there are more and more satellites, we need to keep track of where these satellites are and also other debris in space. And so there exists extensive surveillance networks for these things. And at the CSA, we have an operations center here at our headquarters in Montreal, where we've developed a system called the Conjunction Risk Assessment Mitigation System, or CRAMS. And this keeps track of all the positions of all the satellites and all the known space debris so that we can do corrective maneuvers on our satellites as needed. Also to mitigate or to kind of make sure that we don't increase that number of debris that needs to be tracked. There are guidelines that exist regarding that satellites must be deorbited when their mission ends. So we follow all these guidelines in our CSA missions. So that can either be, if, like I was saying earlier, if a satellite's on low enough orbit, then the atmospheric drag will bring it down. But otherwise, there has to be a deorbiting mechanism on a satellite to bring it down eventually, or that it will be on an orbit that will, fall to Earth quickly. And also, we need to more and more. There's studies on the environmental impacts of launching all these satellites and assets in space. So, for example, the propellants can have impacts on the chemistry of the stratosphere and mesosphere. So this is still an area that's under study, but guidelines are being developed slowly for that. And so we'll be at the CSA for all our missions in Canada trying to adhere to these international guidelines. I'll go brush quickly now because I'm already over 20 minutes in, but this is just some information on how space-derived information is shared across technical communities. So in Canada, we as much as possible, we try to make our space-based data records open, and they are used extensively across our different government departments for various purposes. And also we have that information that we use is shared in international data set repositories, and it is used to inform policy decisions on many topics related to environment and climate change. To also monitor our commitments to various such as things as the Montreal Protocol and other agreements that we have. In the Arctic, one thing to keep in mind is that there are coordination groups that coordinate monitoring of things like sea ice, glaciers, permafrost internationally, and that in Canada we also contribute by field operations, in situ operations. In any satellite mission that you have, such as the ones that I was showing earlier, it's essential also to have some ground measurements to validate and calibrate the satellite data to make sure they're producing accurate results. And so we have some research programs and sites in the Arctic that we use to do such activities, and that we provide such services also for international missions. And finally, in terms of opportunities for cooperation and data sharing, this is just to show that there are several organizations, international organizations that exist that provide guidelines and data sets and try to promote collaboration on data sharing for Earth observation. So notably, there's the GEO and CEOS, which are two organizations that promote share data sets, coordinate observation missions. And these are important, like I was saying earlier, to ensure, one, to ensure that we have good calibration and validation, but also to ensure that we have long-term data sets that we can use to really effectively monitor the effects of climate change. There are programs like NASA's Earth Science Data and Copernicus with the European Space Agency that ensure transparent data sharing and accelerate innovation. One thing of note is the International Charter on Space and Major Disasters. So this is a coordination group that the Canadian Space Agency is involved in. And the way the charter works is if there's a country that has some kind of disaster, so it could be a flood or a landslide, things like this, a major storm, and they want to have better space knowledge of what is happening, they will make an alert. And so we can respond at the space agency to see, okay, did we have any satellites that can be tasked to look at what is happening there and to provide additional data in support of these disaster operations. So this is something that we participate in at the Canadian Space Agency. The UN also promotes the use of space technologies through different frameworks. And finally, I will mention also the World Meteorological Organization, WMO, and they're the ones, for example, who defined requirements for satellite-based climate products, and they also identified that list of essential climate variables that I showed earlier. So they're trying to coordinate what we need to measure to monitor the effects of climate change. So this pretty much concludes my presentation. So a few key takeaways. So climate change is warming. The effects are more prominent in the north. So that's where we have to keep track of what is happening there. There are many environmental climate variables that can be used to track the effects of climate change. And currently there's over 80 satellite missions worldwide that do this. We're planning some future missions to fill in some gaps. In Canada, in terms of the effects of climate change on satellites themselves, there is some evidence that there may be reduced drag impacts that can affect satellite lifetime. We also need to keep an eye on the ground infrastructure, especially in the northern areas. And I presented some of the guidelines for systems to track space debris and ensure sustainability, and international agencies that share and try to promote the use and harmonize the use of Earth observation data to track climate change and the environment. So that concludes my presentation. Thank you very much. Willing to take any questions.
Thank you, Denis. Okay, I'm on. Excellent. Thank you very much, Denis. That was great. And for someone like me who studies human affairs, 2 feet grounded on Earth, that's a lot of information. We take for granted what we get from space operations without really knowing what's going on. Well, myself, I kind of look up once in a while, but I certainly don't know the details. So there's a lot of very interesting stuff here. So I invite everyone to send their questions or using the queue Q&A tab on the I think you see it here function. Maybe to get things started, I was wondering if you could elaborate a little bit on the Arctic mission, observation mission, and maybe more specifically, I have two sub questions,
Mhm.
if I may, and we have one also coming from our public. Um, what one would be about personally, I'm wondering about a mission like this and space operation, maybe more generally. How much do you, and you kind of hinted at that in one of your last slide, how important is international cooperation, allied cooperation, in particular, given the NATO context of this conference, for what you're talking about, especially in the context of the Arctic mission, given the context that NATO also is much more interested in being active in the Arctic. Canada's defense strategy also mentions the Arctic quite a lot. So just wondering how that sort of scientific
Mhm.
political cooperation, if you will, of space operation matters to what you're doing and what the alliance might be doing. And another sub question to that mission that we got from the CEO of ArcticNet is how the agency is planning to engage with indigenous communities regarding the Arctic observation mission. So just wondering if you
Mhm.
can elaborate on that mission. Thank you.
Sure. Yeah, I'd be happy to. So, yeah, the Arctic Observing Mission, it's if we're keeping the fingers crossed that it will get funded, but it is ticking a lot of boxes right now, which gives us some confidence. And it is so. First of all, it's not just for Canada. The whole northern regions, as I was saying, north of, let's say, 45, 50 degrees, is lacking accurate weather data right now. A lot of the weather information that we take for granted here are high accuracy weather forecasts in the more southern regions, comes from these geostationary satellites. And because they're all located around the equator, they don't see very well in the north, and because of the curvature of the Earth. So there's a lack of data right now, so a lot of weather forecasts are very poor, and this affects currently uh, the livelihoods, frankly, of a lot of communities up there. If they need to, there's a lot of very remote communities, for example, that need to travel by airplane or ship or land that don't have accurate weather forecasts, and you can imagine the north there uh, they have to they have to prepare for that, and things like medical evacuations, emergency conditions, everything relies on good weather, and so this would fill primarily that gap. And so goes beyond science. That's a real operational need we see for the communities, but also you can imagine for defense applications. So DND is very interested in the Department of Defense in Canada is very interested in this and our NATO partners. And we're also collaborating. This is not just going to be built using in Canada. We're looking at opportunities to collaborate. UMETSAT is very interested, for example, in Europe as to partnering for us with some of the key technologies that are needed. So you can see that this is a mission that, and yes, climate change monitoring is part of it, but it goes, I think, way beyond that into ensuring good weather data as a kind of a backbone for any infrastructure that you want to have in the north. And with regards to your second question of we certainly want to engage Indigenous and Northern communities in AOM. That's definitely part of the plan. Right now, the mission is still a ways off, but now is the time to start engaging because we need to make sure that, for example, we've done some very preliminary engagement and we want to be doing some more, but the needs of the Arctic, or I would say Northern and indigenous communities, are not necessarily the same. The kind of weather data they're looking for example, might be different. So we need to make sure that the data products that we would be producing from AOM and from our other missions are shared in an effective way with indigenous communities and those in the north as well. So there are going to be Indigenous engagement is certainly part of the package for AOM going forward.
Okay, thanks. Um, Looking if we have more questions online. Um, so maybe I'm wondering, I'm curious about how you disseminate the knowledge or data that you collect. I mean, how, especially in
Mhm.
I would ask you within Canada, but since this is a NATO crowd as well,
Mhm.
how does that work? 'Cause you get all that data, you collect all
Yeah.
that data. I suspect you do some analysis, but maybe not all of it. But
Mhm.
but whatever exactly you come up with, then how do you make or do you disseminate that knowledge and
Mhm.
those analysis to, say, national defense or NATO allies or whoever needs to know what you think they need to know? Are there any sort of formal processes here going on, or do you
Mhm.
write your report that then you hope someone will read them, or how does that work exactly?
Yeah, no, well, for sure there are portals that exist. So in Canada, but it depends, it's kind of depends on the mission, right? So some missions, the let's say the information is not sensitive, quote unquote, and we can share that, and we have an open data policy in Canada that all of the data that we collect from our let's say scientific satellites is shared. So there is the EODMS is a forget what the acronym means, but it's part of the NRCan, which was one of our departments in Canada. They collect all of the data from the Earth observation missions that we have and share them for the open data. In terms of, however, there are, like I said, some missions have some particularities, such as the RadarSat constellation mission. And so in some of these cases, there can be more sensitive data because these certain kinds of mission can be used, for example, to track certain targets. So you don't necessarily want to have like open data sharing on that. But there are certainly, and I'm not an expert on RadarSat, so I don't know exactly how that data sharing works within, um, in that case, but within our different country partners, let's say within NATO. But um, yeah, that's one aspect I don't know too much about, but I'm pretty sure there's some agreements in place with our partners to share some of this data.
Thanks. So I take from this that it's very mission specific, depending on the mission.
Yeah,
There are different mechanisms and processes that, yeah, that sounds good. Correct?
yeah, and but for sure for a
Okay.
mission like AOM that produces weather data, the plan there for sure is to have open data. Like we want, and
Yeah, yeah.
and the data is also one of the important things with that kind of data is the timeliness is very important. We need to make sure that the time between the satellite doing the measurement and the data being processed and provided is very short. So that's another thing that we're working on more and more is a requirement for satellite missions is to provide very rapid data. If there's a disaster, we don't want to know about it, 3 days later. We need to know it within, in some cases, minutes, right? So this is another aspect that we want to make sure that we have, especially for missions that are related to climate and weather and things like that, that this data is provided as quickly, and also wildfire sat, which I'm working on, that this data is provided as soon as possible to the public.
Thank you. Um, I have to ask that question. I know it's it's sometimes, it's a bit politically sensitive, I guess, but can you speak about the current moment where we see that science infrastructure and certain assets and people and organization are being defunded and degraded? Has that affected what you do at the Canadian Space Agency, or do you see bigger gaps in the future because of that, or can you
Yeah,
speak to that?
yeah, I think there are some impacts at the CSA for us. So the mandate of the Canadian Space Agency is really all about developing the technologies and the satellites and the ground station and all that. So it's more the operational side. So we're not affected so much by these cuts, but for sure, like our partner, we have some partner agencies that, like for example, Environment Climate Change Canada, that are having some challenges, and are can. Um, as far though as what we're talking about here, which is Earth observation, there is still a very strong willingness to pursue these missions, though. There's especially missions like AOM, which and I think one of the key words here that is becoming more and more used is dual use, right? So a lot of
Yeah.
these missions that are ostensibly for it could be for weather data, or for monitoring wildfires or things like that, also have a lot of interest on the defense side. So we're working. We do work. We've always worked closely with that sector, but we're working, even trying to get closer now to kind of see, okay, how can we collaborate on these missions so that we can meet both needs, right? The dual use aspect is being more and more considered in our missions.
Well, thanks for that. I was about to ask about dual use, and or my mind the budget's increasing on the defense side of things through
Yeah,
not only in Canada but throughout NATO, and how much that impacts you or not, or what are possibilities there. There is a 1.5% of the
yeah,
5% commitment to NATO that's supposed to go, or is possibly going towards infrastructure or dual use, whatever the
yeah.
Canadian government or other governments want to do. So if that conversation has started, is there anything specific here you can share, or it's just right now a conversation about possibilities, or
Yeah, well, it's I would say it's more than conversation. It's trying to establish partnerships, and looking at things like requirements too, like how can what are the requirements of that the defense community might have, looking at how we can harmonize with our needs, and to create effective dual use missions. And like you were saying, a lot of these missions that we're preparing can be considered as part of a NATO contribution as well. So that is being for sure factored in for missions like AOM and WildfireSat already. The signs are that at least a part of that mission development can be considered as a NATO contribution. So yeah, all these discussions are in the current geopolitical context are happening
yeah.
more and more, and are being considered.
Yeah. Any other key partner here beyond the NATO alliance that you're working with, or that then maybe NATO alliance nation, allied nation partner with in that sort of space domain, or maybe competitors? How does that work in space? Sorry,
Yeah, well,
if I make any sense, if you
yeah,
understand
well,
the
no, of
intent of
course.
my
Well, we
question. Yeah.
we we collaborate with many countries actually. So our main contributor has been the United States for many years, and also ESA, like the European Space Agency and the European Community. We're strengthening our partnerships there. There was recently an announcement of Canada a Canadian contribution to that. So to strengthen our partnership with our European countries. So. Yes, so Canada, there's some things we can do well, but we're still a relatively small country, and we rely on a lot of international collaborations in our space missions. So short answer, yes. A lot of the nature of our collaborations is really with space agencies in terms of actually developing
Yeah.
the assets and the satellites, but of course the data is for NATO, for example. Anything that's dual use, that has a use, is considered also.
Okay. Thank you very much. Um, I'm not seeing any question online. Any last word on your end, or words of conclusion and wisdom or something?
Well, no, I appreciate the invitation. Thanks. And this was actually a really interesting exercise for us. Like when you guys had approached us initially, we were like, okay, we hadn't really done a specific study on this question of the link between climate change and space missions. So this was actually a useful exercise for us to do as well. And this presentation that I've given to you today, I'll be presenting internally as well, because I think it's an interesting topic, and also good to kind of perhaps give a broad overview of what's happening because it's not everyone's aware of all the things, all the satellites that are up there, but also the need that we have to keep missions going because a lot of these missions that I showed on the previous slide are getting old and they're going to be decommissioned soon. So we need to keep investing to make sure that we have satellites in space to keep tracking climate change, but also to provide all the services that we rely on Earth that sometimes we don't realize how much, like weather, for example, all that data we get from space, we need to make sure that we have a sovereign and continued capacity going to the future because it takes a long time. Like I was saying, that Arctic observing mission, we're really hoping it goes, but it wouldn't be before 2035 or 2040. So we need to really plan far ahead to make sure we have a sustainable system of satellites.
Okay, thanks. I'm being told that we actually have a lot of online question, but the thing doesn't refresh automatically. So now I've
Wow, okay.
so now I can see them. I couldn't see them, and now I'm seeing them. So we still have 8 minutes technically. So if you
Sure.
don't mind, Denis, I'll go through a few of them. Some we've already covered, so I might skip them. But I have one on satellites that can be used for disaster response preparation. So I don't know if you can speak out. We already covered NATO a little bit, but the question basically is how can NATO countries with different space capabilities work together for disaster or on disaster preparation and response? Um, Anything to add there?
Well, like I was saying in one of my slides, so I think in terms of disaster response, I think it's good to be aware that there are programs such as the Charter that exist. First of all, I don't know how much. Well, I'm sure NATO countries participate. This is actually like an international initiative. We often get
Yeah.
warnings from anywhere in the world, right? So for disaster response, I think that's an interesting and effective program. And we have certain assets, like I was mentioning, the radar satellites that are really useful for that because they can see, for example, after an earthquake, they can actually measure where the ground has changed and like they can measure the elevation of the surface super precisely. So they're very useful for even post-disaster like after a wildfire, seeing how they change the vegetation, things like that. So I think for disaster response, that's the main international mechanism that I'm aware of is that international charter on disasters.
Okay, thanks. I think we have time for at least two more. Let me let me try. Um, So to what level are you concerned about the infrastructure stability impacts of the ground station? So, and what sort of preparation are you doing or working on to prevent the collapse of those infrastructure because of permafrost thaw?
Yeah, so that's a good question. I'm not really involved in that kind of operational planning side. I think our job I think in terms of myself, which is an Earth observation scientist working on these satellite missions, is to share, these effects. So for example, doing this presentation and sharing this, I think can promote some awareness of that. I think people are aware. People in the north, I'm sure, are aware that these things are already happening. So this has to come into the planning for future infrastructures. In Canada, as some of you probably know, there's a big push right now politically to build and develop in the north, right? All kinds of
Yeah.
industrial infrastructure, ports, everything. And one of these infrastructures will have to be probably more ground stations. And I think there's some plans that I know of to create more ground stations in the north. So all of these things will have to be considered. And sometimes, unfortunately, it's kind of a reactive thing, right? Like that wildfire I mentioned that burned a fiber optic link. And if later on you realize, well, geez, there's more and more wildfires in the north that we are used to. So, we need to come up with plan Bs, and mitigation. So hopefully that's being considered by the people who are working on these things.
All right, thank you. So we have one We talked a little bit about national defense, but one here is a bit more specific about the armed forces. So
Mhm.
I'm wondering how, if you can expand on how you cooperate with the Canadian Armed Forces, and if you know how to use your data.
Okay. I can't really say too much other than yeah, there are some assets like radar sat that are definitely, I know they're used by the armed forces. I don't know, that's not one of the missions I work on, so I don't really know how that level of collaboration works. But I do know that there is that collaboration there, and we do talk to people at National Defense who are interested in different topics. Like I was saying, I'm involved in wildfire sat, so they're interested in seeing like how that data can help them, and so it's more from my perspective and what I do day to day. It's we are in touch with various people at the Canadian Armed Forces, but how that actually is used in day-to-day operations, I have no idea.
Fair enough.
Yeah.
All right, let me try one last one. And again, apologies to everyone. The thing was not refreshing automatically, so that's my bad. Lesson learned for next time. So you did mention the rise of private companies. So we have
Mhm.
a question here about the requirement for information rate sharing between satellites from different countries and private companies. Question is in essence, is it mainly on a voluntary basis that knowledge or data sharing, or is there a requirement to share?
So of course, being a private company, their focus is to make money, and so they don't have any specific. Well, they have to comply to regulatory things regarding you can't just no anyone can't just like launch anything in space without having some regulatory compliances for communications and things like that. But in terms of data sharing, it's really up to them. But more and more, they are interested in providing data to government agencies as a way to make money, and so they're and which is fine. We're more and more aware that this is the way the world is heading, and if there are commercial data sets that are useful for us and that they're willing to, and it makes more sense for us to buy data than to develop a new mission, we will do that. But of course, the onus is also on them to demonstrate that the data quality is adequate, because we have to be cognizant that sometimes commercial space, the way they operate is they'll send stuff quickly and show us all this nice data, but has that really been calibrated and validated and verified before the government purchases that data? Is that's a whole other area that we're more and more getting into now, and not just us, but I know in the US, NASA and even NOAA are heading more that way, like looking at commercial data by and D&D also, Department of Defense. So we're all looking at that because this is something that has really emerged in the last, I would say, 5, 10 years. And there's more and more companies putting stuff up there and trying to sell us the data. So how to manage that is a hot topic at the space
I
agency
bet.
these days. Yeah.
Uh, Maybe in 10 seconds. I'm sorry again. Apologies to everyone because we're running out of time and I
Yeah.
messed up the Q&A. But any word on Russia and China in this game?
Well, not too much data sharing, unfortunately. It's a shame because I was showing about the mentioning the AOM mission, which would produce unprecedented weather data. Well, Russia already has Arctica, which is doing just that. So they are, but they're not sharing the data with us anymore ever since the events of the Ukraine
Yeah.
war. So so that's just another illustration that, they have a strategic information that we don't have right now in terms of northern weather. So yeah, we have to keep that in mind. But yeah, it's unfortunately, I think there's some collaborations on some aspects, but it's very limited, obviously, with Russia and China at the moment.
Yeah, it's a big question, isn't it? We could have taken an hour just on that one.
Yeah.
Thank you very much again, Denis. That was super interesting. Thank you to everyone for being with us today. And just our next event will be, I think it has been confirmed, but you'll get the info later, I suspect. But you can mark your calendar on for the 21st of May. So I'll see you soon, everyone. Thank you again. and have a good day. Bye-bye.
Thank you.